We're going to start this video with another review. So these are the second set of 6 problems on page 1 of the practice test. So I'm going to let you have a few minutes to look over that. Circle equivalent or different, and then we'll share out when you get back. So go ahead and turn off the recording and come back when you're finished. On this first one, to decide whether they are equivalent or different, we would probably want to simplify this one. So that would be 4 times x is 4x. 4 times negative 2 is negative 8. Now we can see that they are not the same. This is 4x minus 8. This is 4x minus 2. So that would be different. Same thing with the next one. There we go. So with this one, we have to be careful because we are distributing a negative, so be careful with that sign. So negative 5 times positive 2x is negative 10x. Negative 5 times negative 1, 2 negatives make a positive. And this is an error many students make. They write negative 10x minus 5. So I can see where a lot of people would write equivalent, but they are not the same because a negative times a negative is positive. So once again, different. So on the next one, we want to look and see if the two are the same. So we need to first put them in alphabetical order. So this one already is for 2 x's and a y. This one is not in alphabetical order, so when we flip-flop the x and y around, we keep the 2 with the x and then the y, and then we can easily see they are equivalent once they're both put in alphabetical order. So that would be equivalent. 4x squared y and 4x squared y. Okay, now up here, when we did 2/3, 2 divided by 3, we can see it's 0.66666666666666, and that 7 is just rounded at the end. The calculator has that built in to round it after it runs out of spaces to put any more numbers. So it's really 6's. There's not a 7 there. That's just a rounded value. So we saw that this is not the same thing as this. So we should use that same approach for this one. 1 divided by 2, and we can see that's exactly 0.5. No rounding required. So that's the difference between these two. To get that answer, you have to round. Rounding is not equivalent. That's called approximate. Where here, it's exactly 0.5. No rounding. So that one is equivalent. So that's the difference between the two. The calculator gave exactly that value. The calculator did not give that value. And we talked about these two earlier in, I think it was in lesson 1. So on this first one, we have to put in a 1. So we're taking negative 1 times x, which is negative x, and negative 1 times 3, which is negative 3. So once we've distributed, we see that they are identical. So negative 1 times x, negative 1 times 3, negative 3. Same. So you can see sometimes you have to simplify one of them, maybe change its form before you can compare them. And last but not least, this is really just asking, is multiplication commutative? And if you don't know, just find the answer to each. The answer to this one's -6. The answer to this one's -6, which tells us multiplication is commutative. Order does not matter. Remember, the two where order matters are division and subtraction. Not equivalent, not equivalent. But this one we can see by working each one out. One negative gives us a negative answer, and they're both -6. So these are equivalent. And that would be the same thing if we did addition. -3 plus 2 equals 2 plus -3. Addition and multiplication, order does not matter. Okay, so let's move on to page 11 for the second part of our, as I said, lesson 4 has 2 parts. The first part was solving proportions, which we completed in the first 2 videos. The second part is solving inequalities. Good news is, remember in lesson 1 when we worked on this, because I said a lot of students have a hard time with the notations and the graphing. So hopefully looking back at that, remembering that will help you with this. So on all of our inequality problems, they have 3 parts. First, they ask you to solve, which means get x alone. Second, they ask you to graph. So I'm going to be graphing each of these out here so we can see the graph. And then I'm going to introduce set builder notation too. We don't have set builder notation, but in the next class they do. So it's good that we review this. So this is x, looks like an L, less than or equal to 2. So we know that's a solid circle if we have the equal sign, and we learned it's open circle if there's no equal sign. We're going to be using parentheses and brackets instead, but we said when we did this in lesson 1, brackets or solid circles, doesn't matter. It's just whatever, of course, the program asks for. Open circles or parentheses, again, doesn't matter. But in your upper level classes, you will only be using brackets and parentheses. So that's how we're going to practice. So we find 2, and I'm not going to make total full-blown number lines. I'm just going to put the number there. Since this is L, remember the L's go together. Looks like an L. It's red less than, and you shade left with a bracket. So you put a bracket at 2, and you shade left. And we learned that on the left end of the number line is -infinity. And then we take these 2 endpoints and put them in the exact same order. -infinity on the left, 2 on the right. We learned in lesson 1, infinities always get parentheses, and this 2 will get a bracket because of the equal sign. So equal signs mean brackets. No equal sign, parentheses. And remember how I taught you to remember that? This is an equal sign. Brackets contain equal signs, because look at the equal sign. It's an equal sign, and then we connect them. It's an equal sign, then we connect them. That's how I remember brackets go with equal signs, because they have an equal sign, and then we just connect them to make the bracket. So that's an easy way to remember it. This one is read x is greater than -4, no equal sign, so this one will have a parenthesis. So we find -4, we know greater than shades to the right, and because there's no equal sign, we use a parenthesis. And then to write our interval notation, on the right end is positive infinity, so we bring these 2 numbers over in the exact same order. -4 infinity, -4 gets a parenthesis because there's no equal sign. Infinity always gets a parenthesis. And last, this was the last type we talked about, or actually they were mixed together in lesson 1. This means x is between -2 and 1. So we make a number line, -2, -1, 0, 1. And remember, the number lines will be drawn for you. You just have to place your parentheses in and then click in the middle to shade it. Here you'd place your parenthesis and click on the right for it to shade it. Place your bracket, click on the left to shade it that direction. So -2 will get a parenthesis because there's no equal sign. And 1 will get a bracket because there's an equal sign. And since X is in between, we know to shade in between those two numbers. So X is in the middle of or in between. And remember, X are your solutions. So your solutions are in between -2 and 1. For interval notation, we bring over the two endpoints in the same order, -2 on the left, 1 on the right. -2 gets a parenthesis, 1 gets the bracket. So all of those we did several problems in, what was it? Lesson 1. Set builder notation is the only new thing here, and it's that set symbols X such that, and then you just place the answer right after the such that symbol. X such that, then you take the answer and place it right after and close your set. X such that, take your answer, place it, close your set symbols. So it's easy to remember this is set builder notation because it uses the set symbols. These symbols are called set symbols. Just like when we were doing solution sets, we would put our answer inside there because this is the solution set. So set builder will always have those little squigglies, where interval notation only has parentheses and brackets based on whether there's an equal sign in the problem. Okay, so all that except for the set builder you should already know. So what we're going to focus on in this section is actually solving the problems. And then we'll write the answers using interval notation and graphing. And we'll do set builder too, just to keep practicing because I know you need it for the next class. So we solve inequalities just like an equation. So we're trying to get X alone. To get it alone, we do the opposite. So for instance, on this one, it would be subtract 6, subtract 6. So everything about solving inequality is exactly like solving an equation, except for one thing. And this is it. And you probably want to use a highlighter on this to highlight and remind yourself, because this is an important part of almost every class you do after this, is solving inequalities, because we use inequalities to find the domain of a radical function. We use inequalities to find the domain of a log function. So, and domain is a big part of your future classes, so you won't be solving inequalities so much, just solve an inequality, but you'll be solving inequalities when they ask you domain questions. So as an example, so if you multiply or divide by a negative, that's the only time you will reverse the symbol. So this will only happen usually on the last step because that's usually the only time you're dividing, right? We hardly ever multiply during an equation unless there's division in the original problem, which not too many are. So on the last step, if you divide by a negative, that doesn't mean subtract. This is subtraction. So if you divide by a negative, you flip the symbol. So I just put a real simple example here. I need to get X alone. The opposite of times -3 is divide by -3. I just divided by a negative. Therefore, this less than symbol turns into a greater than symbol. Rest of the problem's done the same way, but on that last step, you do need to flip it because you divided by a negative. and then double negative, positive. So that turns into 1x. Flip the symbol, greater than. 6 divided by negative 3 is negative 2. So everything else is the same except that one rule. This problem doesn't even have division in it. So you know you're not going to flip your symbol for that because there's not even a division step. So after you solve it, which we have, we know when we've had it completed because it will have x all by itself on the left. So then I find 3, and I'm just not going to make out the whole number lines. We'll never get through this video if I do. I'm just going to put the one that's here. So put your 3 in. This is read less than. All the L's go together, less than, left. So shade left, including the arrow like we learned how to do in lesson 1. And then we decide parenthesis or bracket, no equal sign, so this gets a parenthesis. So that's step 1. Well, actually step 1 and 2. Solve the inequality, graph the inequality. Then they ask you to write the answer in interval notation, and that's where you'll use this notation here. So we have to label this before we do interval notation. You won't label it on your graph in Alex, but on your paper you can. And then you drop it in the same order. Negative infinities on the left, 3's on the right. Infinities always get a parenthesis, and 3 will also get a parenthesis because it's not equal. And then let's just practice a couple with the set builder. So this is interval notation. This is graphing. This is solving. According to these directions, we're done. But I just want to practice on set builder a couple times because you'll need it for your next class. So then I look at what variables used x, and I use my set symbols and do x such that, and then I just plop the answer in the problem. So there's hardly any work to set builder notation. You just simply put your set symbols in, put your x such that, and then you plop your answer in, close the symbols. To me, it's just like a pretty way to write your answer. These are much more important in my book, but I do know that when you're solving inequalities in the next class, they have you write it using set builder as well. So I think they have you do all 3 of these. So they have you solve, and they say write your answer in set builder. So this is part A. Then they have you write interval notation, part B. Then they have you draw the graph. Okay, so let's do another one, and then I'll let you guys practice on a couple, or at least one. I think you might be able to do both 3 and 4. So let's get through this one first. So this one we have x's on both sides. So we need to subtract 7x in order to move it. And don't get subtraction mixed up with dividing by a negative. That is not dividing, that's subtracting. Not the same thing. Division will always have the fraction bar to indicate that it's dividing. So all x's on the left, and this one, it's not optional. The x must be on the left or you will graph it incorrectly. So they have one on one of your quizzes that looks like this, and they ask you to graph it. Well, you can't graph it when x is on that side, so what you have to do is flip the whole thing over. So you write x, it's pointing to the x, so when you flip it over, it has to still be pointing to the x, so you flip the symbol too, and then you do the 3. Because here you're going to say, oh, 3 is greater than x. This is a greater than problem. I'm shading right. Nope. It's actually a less than problem when you write it the correct way. So you will be shading left. So see how you will shade wrong every time if you leave it like this. So just totally flip it over. So x goes on the left. I like to do the eating thing. It's eating the 3. So when I flip it over, it still has to be eating the 3. and these are the same. But this is the form you want it in before you draw the graph. Otherwise, you will draw it incorrectly. Okay, so that leaves me with 1x, or just x, minus 2 is greater than or equal to negative 4. And next, we need anything without an x over to the other side. So we do the opposite to cross the inequality. Opposite of subtract 2 is add 2. So I get x is greater than or equal to negative 2. This cancels. Again, I did not do any division in this problem, so you would not flip the symbol. I did not divide by a negative. I didn't even divide at all. So greater than, because it doesn't look like an L, means shade to the right with a bracket because of the equal sign. So there's our graph. Then we have to do our interval notation. Bring down the negative 2, bring down the infinity. Infinity is always a parenthesis, negative 2 is a bracket. And we'll do one more set builder notation just to practice. So first I look and see what letter they're using, x, such that, and then I just plop my answer in there. X is greater than or equal to negative 2. So graphing, interval notation, set builder notation. Okay, go ahead and turn your video off and try the next two. If you can't completely get them, that's fine. The whole idea is that you're trying them. You're seeing where your weaknesses are. What do you need to practice on before you do your ALEKS work? So just go ahead and turn the video off, and be sure you don't have to do set builder. I think we got the gist of that. Just do the other three. Solve it, graph it, write your interval notation. Okay, so do those two and then come back and we'll see how you did. Okay, on this first one, this is -6 times x. So divide both sides by -6. And there's the key words. I'm dividing, because the opposite of times is divide, by a negative. So before I even do the next step and forget, I immediately flip the sign so I don't forget. So dividing by a negative, first problem we've done in this section where we divided by a negative. So double negative, positive. 6 divided by 6 is 1. So we get x is now greater than, a positive divided by a negative is -3. So there is my solution. I can see it's greater than now, so I'm going to be shading right, and it's going to be a parenthesis. So label your -3, shade right, use a parenthesis, and label your infinity to get ready for your last step, interval notation. So parenthesis, -3, comma, infinity, always a parenthesis. There you go. There's the 3 parts you're going to be asked for. Okay, the next one was a little bit tougher, wasn't it? A little bit more work, but great practice. This would be a perfect one for a test question. Perfect. A little bit of work, but still testing your skills here. So we have 2x minus 6 minus 1 is less than or equal to 3x plus 6 minus 14. Trying not to run into the graph there. So 2x minus 6 minus 1 less than or equal to 3x plus 6 minus 14. So before we start moving, remember we have to do like terms. So there's 2 like terms there, 2 like terms here. So when the signs are the same, we add and keep the sign. So that is 2x minus 7. Less than or equal to 3x. Signs are different, so we subtract. 14 minus 6 is 8. Keep the sign of the larger, so that'll be minus. And now we just have a normal little easy problem after that. So x's must, not optional, must be on the left with inequalities, and that's why I taught you it that way from the beginning, so you wouldn't have to change your ways and start doing stuff different. We've been bringing x's to the left the entire time. So do the opposite of plus 3x, which is minus 3x, and they'll cancel. And then we get negative 1x minus 7 less than or equal to negative 8. We haven't done any division. Like I said, division's always the last step. So you're not going to be flipping the symbol unless it's the last step. And you're dividing by a negative. So I need all of my constants to the right. So do the opposite, just like when solving an equation. And we get negative 1x is less than or equal to negative 1. So negative 1 times x is less than or equal to negative 8 plus 7 is also negative 1. And again, we're dividing by a negative. That means we have to flip the symbol. So we're dividing. The opposite of multiply by negative 1 is divide by negative 1. So x, double negative, get rid of those. Immediately flip your symbol so you don't forget, because we just divided by a negative. Flip the symbol. Dividing by a positive doesn't flip it, only a negative. And 1 divided by 1 is 1. So this is x is greater than or equal to 1. So label your 1 there, put your infinity there, and last step, write your interval notation, keeping them in the same order. Move the mouse out of the way there. And so that is going to be bracket 1 comma infinity. And I will tell you, when people draw the graph first on their paper, because the bad thing about ALEKS is sometimes they have you write interval notation before they ask you to make the graph. And so students try to do the interval notation without having made the graph. Do it on your paper. You'll never miss it if you make the graph first. But the students that try to do it in their head, get the order mixed up, forget the bracket. So always graph first. Even if ALEKS doesn't tell you to graph, put your graph on your paper, then write your interval notation, because it comes directly from the graph. So I hope you guys did well on those. But anytime you miss one that you had a chance to do, make a note of what you did wrong so that you don't do that mistake again. Okay, I can already tell these are both going to be the special cases. Remember, the special cases are all real numbers or no solution. How do I know that? Because I see this is going to be 4x and this is 4x. This is going to be 3x and that's 3x. But you can't guess which one it's going to be. You have to do the work and see if it's always true or never true. Always true, all real numbers. Never true, no solution. AANN. So let's have at it. So this will be 4x plus 8 is greater than 4x plus 15. So 4x plus 8 is greater than 4x plus 15. Subtract your 4x because all my x's must be on the left, and what happens is they cancel on both sides. Remember, do not write x down there. This is not 1x. It is 0. And this is 0. There are no x's left in the problem. So you bring down the next line. 8 is greater than 15, and you ask yourself, is that true or false? And I just go back to how I learned it in grade school. Is it eating the big one? No, it is not. That is a false statement. Never true. It's not eating the big one. False statement. So we write no solution, either with the empty set symbols or no solution, depending on which one's given. So just like with an equation, you cancel out your x's on both sides, and then you decide whether it's a true or false statement. It's not eating the big one, and this is read 8 is greater than 15, not true. So no solution with one of these symbols. Okay, last one on this video. So we have 3x plus 3 is greater than or equal to 3x plus 3. So we need all of our x's on the left, so do the opposite. And a lot of students have trouble with this one. They don't know whether it's true or false. They go 3 greater than 3. Nope, not true. Well, you got to read that too. It says greater than or equal to. 3 is equal to 3. So this is a true statement. Now, if it didn't have an equal sign, that would be false, because 3 is not greater than 3. But because the equal sign's there, is 3 greater than? No. Is 3 equal to? Yes, because that's read greater than or equal to 3. And 3 is equal to 3. So this is always true. And always true is all real numbers. Oops, and I just realized I forgot to tell you about this. You can't do interval notation for no solution, and the graph on no solution is left blank. Because there's not a solution, nothing to graph. But on this one, always true means all real numbers, and that means you shade in the entire number line, because this is the set of real numbers right here, and shade in both the arrows. So any number on the number line will work. Here, no number will work, so the number line's left blank. But all real numbers, entire number line is filled in, because this is the number line of all the real numbers. Interval notation would be negative infinity to positive infinity. And remember, if they did ask you to do set builder for this, and I showed you this on lesson 1, is x, such that x is a real number. I don't know if they'll ask you that on your quiz or test, but just in case you're ready. Okay, that's it for this part of the lesson. We have one more page and we'll be done with lesson 4. So we'll do that on the next video. So see you in a bit.